Hello everyone, I welcome you all to this presentation. So in this video, we'll see about what is context-free grammar and what are the basics of context-free grammar and how we can write the grammar for a language, and then we see about what are the different types of derivations and the parse tree and ambiguous grammar. These are the contents of a presentation. First we see about the introduction, definition, derivation, parse tree, ambiguity, language of a grammar, and the summary. First one is the introduction. So what is context-free grammar? Okay. So context-free grammar is a formal grammar which is used to generate all possible strings in a given formal language. Okay. So it is a formal grammar which is used to generate all possible strings in a given formal language. So next one is, what is context-free grammar? How we can define the context-free grammar? So what are the things present in the context-free grammar? Okay. So actually the context-free grammar can be defined using 4 tuples. So it consists of 4 elements, that is terminals, non-terminals, start symbol, and the production. Okay. So first you see what is terminal. Okay. So the terminals are the basic symbols from which strings are formed. Okay. And next one is the non-terminals. So these are the syntactic variables that denote the set of strings. This helps to define the language generated by the grammar. Okay. And next one is a start symbol. So one of the non-terminal in the grammar is denoted as a start symbol. Okay. And next one is a production. How we can write the production? Okay. So it specifies the manner in which the terminals and non-terminals can be combined to form strings. Okay. So it specifies the rules for which the terminals and non-terminals can be combined to form a string. Okay. And each production consists of 3 things. Okay. So first one is a non-terminal, then we have an arrow followed by a string of non-terminals and terminals. Okay. So usually the terminals can be represented using a small case letter as well as digits, punctuation symbols, and special characters. Okay. And then we have a non-terminals. So non-terminals can be usually represented using a uppercase letter, and one of the symbol in the non-terminal can be considered as a start symbol. Then we have a production. Okay. So next you see how we can define the grammar. Okay. It's a definition of a grammar. So here the grammar can be defined using a 4 tuple. So one is a variable, then we have a set of terminals, then we have a production, and then we have a start symbol. Okay. So V is a finite set of non-terminals or variables, and sigma is a terminals, and P is a set of productions or set of rules, and then S is a start symbol. Okay. So here G represent the context-free grammar. So here each productions of the format A tends to alpha. So where A is a element of set of variables. Okay. It may be any variable, and then alpha is a, so it is a set of strings of variables as well as the terminals. Okay. So it's a mixture of both variables as well as the terminals. Okay. So 0 or more number of terminals. Okay. So it's a definition of context-free grammar. This is a way we can formally define the context-free grammar. Okay. So next one is, we'll see how we can write the grammar for a language. Okay. So we'll see the grammar. So we'll see the language L equal to A power n, where n is greater than or equal to 1. Okay. So this is a language given in the question, and you are going to write a context-free grammar. Okay. Suppose consider, so we are going to write a grammar G, and it have 4 components. Okay. Variables, terminals, then productions, and S. S is a start symbol. Okay. So consider we have only one variable. Okay. So V equal to only S. Okay. And then we have a terminal. So we consider we have only one terminal, that is A. Okay, and then we have to write the production rules. Okay, production rules. So I am considering two production rules. Okay, so for example, so if you consider this language L equal to a power n, where n is greater than or equal to 1. So for example, n value equal to 1, the smallest string that can be derived from the language is a. So I am using the first production as s tends to a. Okay, and then I have to derive more number of a's, so I have to use the production s tends to as. Okay, so next we check whether this grammar derives the string a power n or not. Okay, so you start from the start symbol. Suppose consider if you want to derive this single a, so apply the second production, so you'll get s tends to a. And if you want to derive the two a's, means apply the first production s tends to as, then this instead of as you will apply a here. Okay, so you will derive two a's. Similarly, you can derive 3 a's, 4 a's, 5 a's, like that. So you can derive n number of a's. So this grammar derives the string L equal to a power n, set of strings of a's. Okay, so this is the way we can write a grammar. Okay, we'll see how we can write, okay, how we can find the language generated by the grammar. Okay, so in this case, so the grammar is given, so you are asked to find the language. Okay, so here it is a grammar. Okay, so the grammar consists of yes, the variable s, then we have two terminals a and b, and we have two production s tends to asb and s tends to ab, and here the start symbol is yes. Okay, so you have to derive the strings from this grammar. Okay, so you have to start from the start symbol yes, so apply the production repeatedly and derive the strings. Okay, so after applying the production repeatedly, okay, first one is you apply the production asb, so instead of yes you have to apply either this production or this production. Okay, so you can derive as many number of a's as b's. Okay, so you can derive n number of a's followed by n number of b's. Okay, so you can write the language L equal to a power n, b power n, where n is greater than or equal to 1. Okay, so this is a way we can generate the language. Okay, we can generate the language. Okay, otherwise you can write the set of strings derived from this grammar. Okay, next one is derivation. Okay, so first we see what is derivation. So derivation is a process that generates a valid string with the help of a grammar by replacing the non-terminals on the left with the string on the right of the production. Okay, so actually in the production we have three things, right? So we have a left hand side non-terminal, then we have a arrow, and then right hand side we have any number of terminals or non-terminals, right? So at each step in the derivation, what you do is we have to replace a non-terminal by its right side. Okay, so non-terminals on the left with the string on the right side of the production. Okay, so we'll see one example for this derivation. So for example, consider the grammar for arithmetic expression, that is e tends to e plus e, then e star e, e minus e, and id. Okay, so to generate a valid string, okay, for example, consider we have a string minus of id plus id. Okay, so you have to derive the string, we have to derive this sentence from this grammar. Okay, so you start from the start symbol e. Okay, first we need to have a terminal minus. Okay, we need to have a symbol minus, so you start with the production minus e. So e tends to minus e. Then we need to have a symbol bracket. Okay, so you need to apply the production e tends to bracket e. Okay, then we have to apply the production id plus id. So we need to apply the production e plus e. Okay, so here e plus e. Then you have to replace the leftmost variable by id, then next e variable e by id. So at last you will get minus of id plus id. Okay, so this is a way we can derive the string from the grammar using derivation. Okay, next one is, so we have to see what are the different types of derivations. Okay, we have two type of derivation. One is a leftmost derivation and another one is a rightmost derivation. Okay, so in case of leftmost derivation, what you do is the leftmost non-terminal in each sentinel is always chosen for replacement. Okay, so this is what leftmost derivation, that is at each step of the derivation what you do is you have to replace the leftmost non-terminal by its production, means it is called as leftmost derivation. Okay, and in case of rightmost derivation what you do is you have to replace the rightmost non-terminal by its production. Okay, at each time in the derivation what you do is you have to replace the rightmost non-terminal by its production. So this is what the difference between the leftmost derivation as well as the rightmost derivation. Okay, so next we have to see one example of leftmost derivation as well as the rightmost derivation. Okay, so take the same arithmetic grammar, e tends to e plus e star e minus e and id. Okay, and consider the sentence minus of id plus id. Okay, so first we see about the leftmost derivation, then we go for the rightmost derivation. Okay, so in the leftmost derivation what you do, at each step in the derivation we have to remove the leftmost non-terminal by its production. Similarly in case of rightmost derivation what you do, so you have to replace the rightmost variable by its production. So this is the difference between the leftmost derivation as well as the rightmost derivation. Okay, so first you have to apply. Okay, for example the sentence you have to derive as minus of id plus id. Okay, the first symbol is minus, so you have to apply the production e tends to minus e. Then the next symbol is bracket, so you have to apply the production instead of e you have to replace this by bracket of e. Okay, then we need to have a sentence id plus id, so this non-terminal e can be replaced by e plus e. Okay, and then now we apply the leftmost derivation. So the leftmost non-terminal can be, the left hand side non-terminal can be replaced by id. Similar way, so in the next step the next leftmost variable can be replaced by id. Okay, so this is what leftmost derivation. Okay, so next you see about the rightmost derivation. In case of rightmost derivation, so first we apply the production e tends to minus e, then minus of e. Okay, then we have to apply e plus e. So here the rightmost non-terminal is replaced. Okay, see the difference. Okay, so in case of leftmost derivation the leftmost variable is replaced, but in case of rightmost derivation we have to replace the rightmost non-terminal by its production. So the rightmost variable e can be replaced by id, then the next rightmost variable can be replaced by id. Okay, so this is what leftmost derivation as well as the rightmost derivation. Okay. Okay, next one is parse tree. So parse tree is a diagrammatic representation of derivation derived from the grammar. Okay, so each and every steps okay in the derivation can be pictorially represented using the parse tree. Okay, so other name of parse tree is a derivation tree. Okay, so parse tree is a pictorial representation of sentence obtained from the grammar. Okay, so in a parse tree each interior node represent the non-terminal, and the children of node can be either terminal or non-terminal of the sentential form that can be read from left to right. Okay, so here there is one definition, that is yield of a parse tree. Okay, so if you read the labels of the leaf node from left to right, so it give the yield of a parse tree or frontier of the parse tree. Okay, so what is yield of a parse tree? So when you read the labels of the leaf node from left to right, so it give the yield of a parse tree. Okay, so parse tree is a diagrammatic representation of derivation derived from the grammar. Okay, also it is a pictorial representation of sentence obtained from the grammar. Okay, so next you see one example of parse tree. So here parse consider the same grammar. Okay, same arithmetic grammar, e tends to e plus e star e, then e minus e, then the id. Okay, and then you have to consider the sentence id plus id star id. Okay, you are going to derive the parse tree for the sentence id plus id star id. Okay, so you start from the start symbol e. Okay, first you have to do id plus id, so you have to apply the production. Okay, you have to replace this non-terminal by e plus e. Okay, then I need id star id, so the rightmost variable e can be replaced by e star e. Okay, then every non terminal e can be replaced by its production id. So when you read the labels of the leaf node, okay, from left to right, it will get id plus id star id. So this will be the yield of a derivation tree. Okay, so when you read the labels of the leaf node from left to right, so you'll get the yield of a derivation tree. So that is the sentence you are going to derive, that is id plus id star id. Next is ambiguity. Okay, so you'll see what is ambiguity, what is ambiguous grammar. Okay, a grammar that produces more than one parse tree for some sentence is said to be a ambiguous grammar. Okay, suppose consider we have a grammar. Okay, so if the grammar has more than one leftmost derivation or more than one rightmost derivation or more than one parse tree for a particular sentence, we call the particular grammar as a ambiguous grammar. Okay, so we'll see one example in the next slide. Okay, suppose consider we have a arithmetic grammar e tends to e plus e star e, then e minus e and id. Okay, and you are going to derive the sentence id plus id star id. Okay, so for this sentence you are going to prove this grammar is an ambiguous grammar. Okay, so how we can prove? So for the particular sentence, if we have two leftmost derivation or two rightmost derivation or two parse tree, we can say the particular grammar is an ambiguous grammar. Okay, so for the sentence I will first I will derive two leftmost derivation. So here first what you do, I will apply the first production, that is e tends to e plus e. I am using the leftmost derivation. At each step in the derivation, I have to replace a leftmost non-terminal White's production. So at last, I will get the id plus id star id. Okay. So next, for the second leftmost derivation, I apply the second production, that is e tends to e star e. So in that case, what you do? Again, the leftmost non-terminal is replaced by its production. So at last, I will get id plus id star id. Okay. So again, we have two leftmost derivation for the same sentence, id plus id star id. Again, for the two leftmost derivation, I have to draw two parse tree. Okay, so here we have two parse tree for the same sentence. Okay, so we can prove the grammar is a ambiguous grammar. This arithmetic grammar is a ambiguous grammar. Why it is a ambiguous grammar? So it have two leftmost derivation as well as two parse tree, as well as this grammar also having two rightmost derivation also. Okay, so we can say the arithmetic grammar. Okay, so e tends to e plus e star e minus e and id is a ambiguous grammar. Okay, because it have two leftmost derivation as well as two rightmost derivation as well as two parse tree. Okay, so this way we can prove the grammar has a grammar is a ambiguous. So next one is a language of a grammar. Okay, so the language of a grammar is called as a context free language. Okay, so we'll define the language. Okay, it is a set of strings that can be derived from a grammar, is said to be a language generated from that grammar. Okay, so it is a context free grammar. The language of a grammar, context free grammar, is called as a context free language. Okay, so it is a set of strings derived from the grammar. Okay, so it is a context free language. Okay, so how we can define the language? Okay, the language generated by the grammar G is a subset. Okay, so L of G equal to set of strings W such that where W is an element of sigma star, it may have set of terminals. Again, it should be derived from the start symbol, where S represents the start symbol. Okay, S derives 0 or more number of steps. Okay, more number of times. Okay, we can apply the derivation. At last, we will derive the terminal, set of terminals. Okay, W is a string that contains only the terminals. Okay, so it is a language of a grammar. Okay, you understand? So this is what a context free language. Okay. So next is a summary. So in this presentation we discussed about basics of context free grammar and what are the steps we have to write the context free grammar for a language, as well as different types of derivations, parse tree, and the concept of ambiguity. Okay, thank you.